Picture a factory, a massive, sprawling manufacturing plant. Normally, when you think about upgrading that factory, you imagine human engineers walking the floor.
Right. With clipboards,
Yep.
designing better conveyor belts, bringing in faster robotic arms.
Exactly. And slowly optimizing that whole assembly line over years. But now, imagine if the robotic arms on that assembly line suddenly, well, they just started designing, printing, and installing their own firmware updates.
Completely on their own.
Yeah, without asking for permission. They begin rerouting the factory's internal supply chains. They construct newer, faster robotic arms. And they do all of this continuously while the human engineers just stand behind soundproof glass, like just watching the factory evolve in real time.
Because you are no longer building the product, you are watching the product build itself. And, we're looking at a threshold that changes the fundamental physics of technological progress here.
It's wild.
Yeah.
And this isn't speculative fiction about artificial intelligence anymore, by the way. Today, we are examining leaked internal data.
Right. Specifically, a 2026 report from Anthropic titled When AI Builds Itself.
Which proves that recursive self-improvement is actually already in motion inside the world's frontier labs.
It's happening right now.
So, okay, let's unpack this. We are bringing this newly published data directly to you to cut through the noise. Because the mission today is to look at the hard, previously unreported metrics of how AI is accelerating its own development.
We need to explore the actual mechanics of how it's happening and, frankly, examine the massive geopolitical coordination problem this creates.
Right. And to understand where we're going, we first have to look at the timeline of how fast autonomy is scaled. Because the ground is moving incredibly fast under our feet.
Oh, absolutely.
Like, just think back to between 2021 and 2023. Building an AI model like the first iterations of Claude was just standard software engineering. It was humans typing out code line by line.
Yeah, completely manual. And then we hit the chatbot era right around 2023 to 2025. Humans were still driving, but we were using early AI to generate snippets.
And manually copying and pasting them into development environments.
Exactly. The human was the manual router of information. But the shift in 2025 and 2026 introduced coding agents. And these were capable of writing and editing entire files natively within the code base.
So the human stopped being a router and basically became a manager.
Right. And that brings us to the current paradigm of autonomous agents. The system architecture has fundamentally changed. An AI agent today doesn't just run code.
It's acting as a primary orchestrator, right?
Yes. It delegates complex, multi-step work to other specialized AI agents.
Let's break down the mechanics of that delegation, because that's the core of what Anthropic calls closing the loop. Like, if a system needs to migrate a database, the primary agent isn't just writing a simple script.
No, it's spinning up a sub-agent to analyze the legacy schema.
And another one to handle the API routing. And another one to write the front-end updates. It's like fractal management.
That's a great way to put it. The AI is creating its own temporary workforce, managing all the dependencies, and then merging the final result.
Which means the system is becoming increasingly capable of building, training, and improving its own successor without a human even in the loop. It's like we've gone from AI being a fancy spell checker
to co-author.
Right, and now it's basically the entire publishing house. But, I mean, is there actual proof that the AI's attention span is growing? Or is it just doing the same short tasks a bit faster?
Oh, there is outside evidence, and it focuses heavily on sustained attention span and reliability. The length of time an AI model can reliably execute a task on its own has been doubling roughly every 4 months.
Wow, every 4 months?
Yeah. Look at March 2024. Claude Opus 3 handled software tasks that took humans about 4 minutes to complete. Just 1 year later, Claude Sonnet 3.7 was managing tasks that took a human an hour and a half.
That is a massive jump.
And by March 2026, Claude Opus 4.6 is successful in managing 12-hour continuous tasks.
12 hours of autonomous work. So if that doubling trend holds, we're looking at systems executing weeks-long tasks autonomously by, 2027?
Easily. And you see this reflected in the industry benchmarks, too. Take SWE Bench, which tests real-world software engineering. They hand an AI an open-source code base and a real bug report to fix.
And how did the models do?
They went from scoring in the low single digits to achieving near 100% performance in under 2 years.
In under 2 years.
Yep. And the exact same thing happened with Core Bench, which tests an AI's ability to reproduce published scientific research. It went from a 20% success rate in 2024 to being completely saturated 15 months later.
Okay, but those public benchmarks just show the output. To
Yeah.
really see what's happening, we have to look inside the company itself, which reveals this staggering shift in how software is actually produced.
Right. This is where the Anthropic internal data is just mind-blowing.
It is. As of May 2026, more than 80% of the code merged into Anthropic's entire code base is authored by Claude. 80%.
Which is wild because before February 2025, that figure was in the low single digits.
Yeah. And the result of that integration is that in the second quarter of 2026, the typical Anthropic engineer was shipping 8 times as much code per day as they did in 2024.
8 times the volume.
But wait, any engineer listening to that stat is going to immediately flag that lines of code is a highly manipulated metric.
Yeah.
I mean, isn't 8 times the code just AI generating massive amounts of sloppy bloatware that someone else is going to have to maintain?
That is the exact right question to ask, and the Anthropic paper directly acknowledges that vulnerability in the data. Lines of code heavily favors quantity over quality, obviously.
Right.
However, they pair that metric with subjective internal evidence. They did a poll in March 2026, and it showed the median Anthropic employee estimating they were producing about 4 times as much effective output using their internal model, Mythos Preview.
So even factoring out the bloat, it's a 4x real productivity boom.
Exactly. And it isn't just about typing faster. It's about executing tasks that humans fundamentally avoid due to cognitive limits.
Let's look at a specific application of that from the leak. Because in April 2026, an engineer used Claude to ship over 800 bug fixes that reduced a specific class of API errors by a factor of 1,000.
And the really crazy part, the engineer overseeing it estimated that doing it manually would have taken 4 full years of human labor.
4 years compressed into, what was it, a few hours?
Basically, yeah. And to understand the why behind that 1000x reduction, you have to look at the mechanics of an API error and, well, the limitation of human working memory.
Right, because fixing a widespread API error requires tracing a data payload across a front-end request through a middleware authorization layer into a back-end database query.
And out to an external gateway. That logic is scattered across dozens of different files. A human engineer has to literally page that architectural state in and out of their brain file by file.
Which is exhausting.
It is, but an AI with a 2 million token context window doesn't do that. It holds the entire multi-layered architecture in its active workspace simultaneously.
It just sees everything at once.
It sees the misaligned variables across 50 files instantly, which is why it can execute 4 years of cognitive tracing in a matter of hours.
So the system has fundamentally surpassed human working memory for complex architectural state. And it's not just fixing routine errors either.
No, not at all.
The data shows Claude's success rate on the most complex, open-ended tasks, like the ones where the engineer doesn't even know what the optimal solution looks like beforehand. It hit 76% in May 2026.
That is a 50-point jump in 6 months.
It's insane. And now Anthropic is relying on an automated Claude reviewer to check all proposed code changes. A retrospective analysis found this automated reviewer would have caught roughly a third of the bugs that caused past production incidents.
We are talking about an AI reliably catching the blind spots of the most elite AI engineers in the world.
Which totally forces us to reevaluate the human's role in the development loop. Like if the act of execute, the coding, the architectural mapping, the bug fixing is mathematically solved by the AI, the whole engineering paradigm shifts.
It really does. We move from a state where humans are actively doing the work to a state where humans are merely judging the output of the machine.
And the speed of that execution is where the concept of recursive self-improvement really takes shape. Because when Anthropic tasks Claude with optimizing an experiment, meaning rewriting the code to make an AI training run more efficient, the acceleration is just exponential.
Right, the speedups are staggering.
Yeah. In May 2025, Claude Opus 4 averaged a 3x speedup on these optimizations. By April 2026, Claude Mythos Preview achieved a 52x speedup.
And just for context, the baseline for a highly skilled human engineer to hit a mere 4x speedup is 4 to 8 hours of deep work.
Like the AI is just running an iterative loop.
Exactly. It rewrites the code, compiles it, profiles the execution time, identifies the new bottleneck, and rewrites it again. And it's executing the cycle infinitely faster than human fingers can interface with a keyboard.
It's compounding its own efficiency. And here's where it gets really interesting. It is applying that iterative loop to entirely open-ended research.
This is the part that really shook the research community.
Yeah. Anthropic set up an AI safety experiment to test if a weaker model could reliably supervise a stronger one. But instead of humans running it, They gave the open problem to a team of Claude agents.
And over 800 hours, those agents recovered 97% of the performance gap.
They effectively did the entire job of the human researchers. The humans only provided the initial, high-level direction.
Which brings up a critical philosophical wall. For years, the consensus was that even if AI could execute the experiment, humans would always be required for research taste.
Right. That intuitive, gut-level ability to look at a landscape of possibilities and just, know which experiment is actually worth running. So if the AI can run the experiment, is human research taste the only thing keeping us in the loop?
Well, what's fascinating here is that even this human advantage is shrinking actively. We treat intuition like it's this untouchable human spark. But in reality, a researcher's intuition is just subconscious pattern recognition built on years of reading literature and experiencing failures.
And Anthropic tested whether an AI could replicate this, didn't they?
They did. The most disruptive finding in the entire 2026 report is that research taste is actively being decoded. They took 129 real internal research sessions where a human expert took a wrong detour and pursued a dead end.
Okay.
They paused the timeline right before the mistake and asked their models what the next step should be. In November 2025, Opus 4.5 beat the human's choice 51% of the time, so basically a coin toss.
Right.
But by April 2026, Mythos Preview beat the human choice 64% of the time.
Wow. So it is predicting the dead end before the human expert even sees it.
Yeah.
It mathematically reverse engineers human intuition by compressing, lifetimes of research patterns into matrix multiplications.
Precisely.
Yeah.
And when gut instinct becomes just another qualitative skill that AI masters, like explaining a joke or parsing sarcasm, the last cognitive moat surrounding human researchers evaporates.
So if the AI possesses both the execution speed to run the experiment and the research taste to choose the optimal path, the system closes the loop. The intelligence designs its own successor.
It does.
So if this loop fully closes, what does the global economy actually look like in the immediate future? Because looking at the Anthropic data, we seem to be heading down one of three very distinct paths for you to consider.
Yeah, the report outlines 3 scenarios.
The first scenario is that the exponential trend simply stalls. We hit a hard physical limit in silicon chip fabrication, or the models just exhaust the available electrical grid.
But the report emphasizes that even in a stalled future, today's capabilities widely diffuse across every single industry.
Right, they cite Project Glasswing for this. That was an AI that was deployed and found 10,000 high-severity software vulnerabilities almost instantly across various code bases.
And in that diffusion scenario, the bottleneck for cybersecurity fundamentally shifts. The problem is no longer finding the zero-day exploit. The problem is possessing the infrastructure to patch 10,000 critical vulnerabilities before malicious actors use equivalent AI models to exploit them.
Which is terrifying on its own. But then the second scenario is where the efficiency continues to compound without becoming fully autonomous. Humans are still guiding the ship, but the leverage becomes unimaginable.
Right, a 100-person company essentially wields the productive capacity of a 100,000-person organization.
Every single human employee transitions into an executive manager overseeing a massive multi-layered pyramid of specialized AI agents doing all the underlying research, development, and logistics.
But the third scenario is the one that demands our focus: full, recursive self-improvement. The AI assumes complete control of designing, training, and iterating the next generation of models.
And the pace of technological progress violently detaches from human labor.
Exactly. The speed of advancement becomes entirely dictated by the raw availability of compute power. Human labor literally ceases to be a competitive input in the development cycle.
But wait, even if the AI is a million times faster at software development, Amdahl's law dictates it's going to hit a wall eventually, right?
Yes. Amdahl's law is a crucial concept here. In computer science, it states that speeding up one part of a system just shifts the bottleneck to the unaccelerated parts.
So it's like having a hyperdrive engine in a car that's stuck in rush hour traffic.
Ugh.
The engine can theoretically travel at the speed of light, but it doesn't matter, because the physical and social world is the traffic jam. You still have to wait for the physical cars in front of you to move.
That is a perfect analogy. That collision between infinite digital acceleration and strict physical bottlenecks is going to define our reality. Look, an AI might simulate the molecular structure of a revolutionary life-saving drug in 5 seconds,
Right.
but it cannot simulate the decade-long biological side effects of that drug on a human body any faster than the physical 10 years it takes to run a clinical trial. Oh, wow.
Or
Yeah.
an AI could draft a flawless, mathematically optimized constitution for a nation in an afternoon. But it cannot force a population to hold democratic elections faster than the laws and social trust of that nation allow. The physical, biological, and social worlds run strictly on human time.
Which creates a massive, glaring geopolitical dilemma. We are racing toward this unpredictable collision, and recursive self-improvement inherently increases the risk of losing control over these systems.
Absolutely.
I mean, if the models are designing themselves, the humans behind the glass might not even understand the new architectures being deployed. So the obvious question is, why don't Anthropic or OpenAI or the other leading labs just hit the brakes? Why can't they unilaterally pause and figure out the safety mechanisms before closing the loop?
Well, if we connect this to the bigger picture, AI development isn't happening in a vacuum. It is a classic geopolitical arms control problem.
The paper outlines the game theory of a unilateral pause. If one cautious, safety-conscious lab decides to stop, it doesn't change the structural risk. It simply abdicates the front-runner position.
Because if the responsible actors slow down, it just allows less cautious competitors or adversarial nation-states to catch up and dictate the future of the technology.
Exactly. Which is why Anthropic argues that the only viable solution is a global verification regime. Multiple nations and highly resourced labs have to agree to pause under the exact same conditions.
Mirroring something like the Intermediate Range Nuclear Forces Treaty.
Yes. They need a system where every actor can mathematically verify that their adversaries have also stopped training frontier models.
But the terrifying caveat from the text is the structural difference between nuclear verification and AI verification. Because nuclear treaties rely on highly specialized, easily trackable materials, you cannot easily hide a massive underground missile silo from satellite imagery.
No, you can't. But you can absolutely hide an AI training run.
Because the inputs for AI are entirely general purpose: compute power and electricity.
Exactly. You can look at a massive gigawatt data center from space, but you have no idea what the GPUs inside are actually processing.
Right, it could be rendering the next 3D animated blockbuster movie. It could be processing global financial transactions.
Or it could be secretly training an autonomous superintelligence in violation of a global treaty. Distinguishing benign data structures from the weights and gradients of a self-improving model requires a level of intrusive cryptographic verification that, frankly, doesn't currently exist.
And building the diplomatic infrastructure and the mutual trust required for nuclear treaties took the international community decades.
Decades. And we are trying to build equivalent systems of global deliberation for AI at the speed of the technology itself, a technology that is functionally compounding its own capabilities every 4 months. We simply do not have decades to solve the coordination problem.
Wow. We have covered massive ground today for you. We've tracked the evolution from humans manually pasting code snippets to AI models autonomously orchestrating sub-agents to handle 12-hour tasks.
We've looked at the internal data showing a single AI system authoring 80% of a frontier lab's code base.
And effectively wiping out 4 years of human debugging by utilizing a massive context window. We've seen how the last human advantage, the intuition behind research taste, is being mathematically decoded as just another pattern recognition task.
And we've examined the reality of Amdahl's law, where infinite digital speed crashes into the unyielding physical traffic jam of biology and geopolitics.
Creating an urgent need for an almost impossible global treaty system.
Yeah.
So what does this all mean?
Well, the data in this report forces us to confront a profound question about the human condition. There is a quote from an internal Anthropic employee in the paper that captures this perfectly. They said, "On days where everything works well, I can't help but think nothing I do matters. Everything is automated and better and faster than I ever will be." Yeah. If we reach a point where human labor is no longer economically competitive, when the doing costs absolutely nothing in human time, how will you define your personal purpose? What is your intrinsic value? If the future of humanity is completely detached from economic productivity, our greatest challenge won't be building smarter machines. Our greatest challenge will be figuring out how we choose to spend our newly unbounded time with each other in a world running on human time.
We are no longer the engineers walking the floor of the factory. The factory is building itself now, faster and better than we ever could. Our job is to figure out what to do with the world outside the factory doors. Thank you for joining us on this deep dive. Keep questioning the world around you, keep looking for the bottlenecks, and we'll see you next time.